Go. Awesome. Okay, welcome everybody. I think is this like the first announcement that we've done for the morning? Anyway, welcome to DataFest ArtQuest Saturday, day 2. We're super excited about all the people that we have with us here at the Albuquerque Convention Center today for this special workshop on coding. I know I can say it a whole lot better. Coding for Beginners with Alex Webb. And I'm super excited that Alex decided to come on to our team several months back when we started planning this whole project, because the public art program had the privilege of working with one of Alex's classes at UNM in the School of Architecture and Planning about 5 years ago, where his whole class spent a semester using public art data, which was in its kind of infancy form at that time, and combining it with other open data that was out there in the world. And so we got some incredible projects back that told us how many pieces of public art were next to breweries, or how many pieces of public art were at bus stops, all kinds of fun things. And the best one was how much public art was associated next to locations where people posted pictures of their cats on Instagram. It was something like that, crazy. Anyway, so if you want to get it, this is how I got inspired about public art data and other data. So, without further ado, I'm just super excited that we have Alex Webb, Associate Professor of Emergent Technology and the Stam Professor of Advanced Design and Construction Practices at the School of Architecture and Planning, University of New Mexico. Thank you, Alex.
Thanks, everybody. Thank you, Sherry. Thanks to all of the organizations that came together to put this on. This is a really fantastic event, and I'm very excited that this could be the first of many. These are it's really fantastic to see this kind of open access to data, and then seeing people coming together to figure out what things to do with it. It's great. I think I should make a few disclaimers before we get going. The idea of this course, so basically my idea of what we're going to do today is that everyone here in attendance and everybody who's connected online is going to make a program that does something that they like. That's the goal. That's it. I'm pretty much self-taught in coding. I really learned coding on my own at architecture firms. So whenever I have a computer science student in my class, they'll frequently be like, "You cannot teach this way. Don't do that." And I'm like, "Well, yeah, I mean, I hear you, but this is why." I definitely notice when there's someone in attendance with an MIT shirt and multiple NASA stickers on his laptop. This might be a little different for some people. The thing that my approach is not to provide comprehensive understanding of how code works, and not to make you all expert coders. That, by definition, is impossible, particularly within 3 hours, and definitely for me, because I am not an expert coder myself. What I'm trying to do is get everyone a sense of how to even go about thinking about coding, so that you have enough confidence that after this session, you'll be able to code on your own, sketch things up, try things out, and this is more about sort of setting a trajectory than like providing you comprehensive information, which is really, really, really different if you've ever taken a coding class. So apologies for that. It can be a little unsettling, but we'll get through it. Another thing I've gotten used to, particularly in the next year, is actually having a lot of remote students. That's something that I'm super familiar with at this point. If you are watching this online and you're wanting to join in and you're following along and you have a question, please feel free to ask. There was a Discord server link set out. It's really easy to set up. You can use a web interface for it, and you can send me messages so I can see them, and I'll try to answer your questions. If we ended up getting deluged with questions, I don't think that will happen today, but if we do, and I can't get to them all by one, I will get to them at some point this afternoon or tomorrow, because I definitely want to make sure that everyone's off and running with coding. So that is that's the overview. Of the people who are here who I don't know, which there are 3 of you, have you guys ever had any coding experience before? No. None. A little bit. Yeah. What have you worked with? Okay, so you're going to tell me how to do this. Have you done any Java? Okay, so we'll be going over Java. It's super high level, so it'll probably be super easy. Yeah. Same here. Sorry. Same here. I'm not used to having a mic, so bear with me on that one. No coding at all on your end? A little? Like Python, Java? Yeah, a little bit of Python. Okay. They're pretty similar. There's a couple like core concepts that are different, and we'll get to that, but it's no problem. Guy who knows way more than coding than I do, because you have an MIT shirt on. What am I coding? Yeah. Okay. But that one's very light. Yeah, so for you guys, Java might actually seem kind of like frustrating. And what we're going to be doing today is we're going to be focusing on, yeah, because it's for like newbies. It's not really for people that have done that kind of stuff. But it's also a really helpful way to, particularly processing, is a really helpful way to sketch out more complex ideas before you then implement them in more robust programs. So the guys who actually created or had that in mind to create a digital graphic sketchbook that they would then create and then make happen. If anyone is watching online and they want to post in here what their coding experience is, feel free. Just use the Discord server and I'll check that out. It's definitely helpful for me. Okay, so now I'll open up to everyone in the room, gray shirts included. Was everybody able to get processing, who wants to follow along, able to get processing running on their computers? Was anyone not able to? When you open the file that I sent to everybody, does it look I need this over here. Does it look kind of like this on the screen? Hello world, Println, hello world. Majoron, did you get the? You're opening it. Okay, gotcha. So the processing is a little weird because particularly if you've never coded before, maybe you use something like, if you have, you use something like Ellipse or something, a more robust environment. Processing is really stripped down, which is to try to make things simple and try to make it easy to work within. I personally love writing code in processing because it's so simple as opposed to like something like Ellipse, which is really, really just a lot of stuff going there. Super convenient when you're doing more robust stuff, but if you do really, really light things like I typically do, it's awesome. So once you have a file open and it has a line of code in it, you can, I'm so sorry, tech guys. You can click run, and then you'll see this gray square come up. You'll also see down here at the bottom, hello world, okay? What we've just done is actually before I explain it, go ahead and in the quotations, the purple quotations, change println to change the content of hello world to be something else. Like hiya world. Just it doesn't have to be anything. It's meaningless. Don't overthink it. You hit run, and now you'll see the text show up at the bottom, hiya world, or whatever you wrote. Up to speed so far? Yeah. Yes. Okay, so pure newbies. Here's the thing. You just wrote software. It's that easy. You can use the processing function to export a program that can sit on your desktop, and every time you double click on it, a gray square will come up. You won't see the whatever you wrote. That doesn't matter, but you literally just wrote a program. And this is one of the key things I want to really push today. We often, in academia, we talk about standing on the shoulders of giants, which means that you really don't do anything new. You're always building from work that came before you. This couldn't be more true in coding. If you are using processing, you are using which makes programs, you're using a graphics library that was created by two guys at MIT who then created a whole organization to create that. They were using Java, the Java language, which was developed over years and years and years, and that's based off of other developments as well. So really, the differentiation of when you write a program or when you don't is really, you're always taking something someone else has done and creating your own thing from it. So when I was working at an architecture firm called Gensler, I was basically finding chunks of code that worked for me, stitching them together, and then that was the programs that we used. It didn't really matter that I was using blocks of code that I found. I was still creating something, maybe not super novel, but still novel, because of just finding the right chunks and then making them talk to each other. That eventually, the more and more I did this stuff, more and more that turned into actually less looking and actually creating, and then that, now I can easily, say very confidently I've definitely written programs, but looking back on it, it's not that dissimilar to what you guys just did. So what I'm hoping is that demystifies all this, that you guys are like, okay, you've already written a program, cool. Let's now go through the steps of making a cool program and go through the steps of making a program with data. In this case, public art data that we can then turn into some kind of the beginnings of some sort of interactive map or something like that. So, does that make sense to everybody? Everyone's buying what I'm selling? You're not like this guy's full of it? No, nothing? Okay. If at any point you have questions or you're like, well, wait a second, what's going on here? Just ask. Yeah, believe me, I teach 20-year-olds. I'm used to that. It's basically a daily occurrence, and it's awesome. It keeps me on my toes. I love it. So now we're going to do something a little bit more, graphic. To this point, we've just been using the println command, which is all that does is print something in the console. This is a great way to debug. So if you guys haven't done a lot of coding before, 90% of coding is figuring out what went wrong with the code that you wrote and then solving it. Println is an awesome way to do that because you can, without having to get into the complexities of creating graphics and processing, if you just print that information is going through something, which we will do, it's a way of just kind of giving you feedback that things are working. So that's cool, but we're gonna, to move into graphics, we're gonna actually we're gonna leave that line And we're going to add another line that actually creates a graphic. In this case, it's an ellipse. So type ellipse underneath println. So the ellipse has the ellipse is a command, and you can or a function. You can tell that in processing because it's blue. Things in quotes, which are called strings in coding, are purple. That's a way of saying, hey, this is not something that processing could understand as a command. This is something that is just text for text's sake. But then most other things, we're going to get to one orange thing in a second, but most other things are black, and that'll be just kind of typically things like that are pure input. So the syntax of Java is that there's a function, and then within parentheses, there's inputs to that function. So this is like kind of information that you're giving the function to do something with. In this case, we're giving the ellipse 2 values of 50 and 2 values of 10. The first 2 values are x and y coordinates. So if you guys have done any computer modeling or anything else with computer graphics, usually computer screens are thought of as a Cartesian grid, so that you kind of go a certain amount of pixels over and a certain amount of pixels down in this case, so that by default, processing makes a screen that's 100 by 100. So we're going to make our ellipse 50 at 0.50, a value of 50 and an x value of 50 as well. And then the 2 radii of the ellipse, because an ellipse is a circle with 2 different radiuses. There isn't a circle in processing, but if you just give an ellipse the 2 different radii, it is a circle. There's a circle with a radius of 10 in this case. So if we run this script, we now have a gray square with a white circle in it. I know. Thank you all very much. All right, I'm out. No, we have to do like really stupid basic things in order to like get to the good stuff. I promise you, we're gonna get to good stuff. That's my solemn swear. It will be cool. Yeah. So gray box, white circle, yippee. But we're now creating graphics, so that's pretty cool. We're going to be using ellipses a lot in this, but there's a whole host of processing geometries that you can use. Here's an important thing. Well, there's a couple things I should go over at this point that are, and we'll get rolling in a second. We're still kind of going through the overview type stuff, and I apologize if it feels a little slow. We'll get going. We'll definitely ramp things up, but. If you press the play button, run, which is also either Open Apple R or Control R, which is lovely to just use the key shortcut. If you do run and you see something highlighted and this kind of red thing at the bottom, those are error messages. That just means that there is something wrong. Processing's error messages are maddeningly vague. Just telling you right now. You're going to see unexpected token null a whole lot. Means very little. Like it's not anything usable that's helpful to decode. Chances are it means that you missed a semicolon somewhere. So if you just go on a semicolon hunt, that's great. Without a semicolon, processing doesn't really realize that you've reached the end of a line, more or less. So there's going to be lots of semicolons missing and eventually brackets missing and things like that. That is like, if 90% of our time is debugging, 90% of that time is chasing down missing semicolons and brackets, which we'll get to in a second. But if something goes wrong, check that first. If something else, there's also something else going wrong, just check spelling and make sure that the things that should be turning blue, like commands and functions, are blue. If they're not blue, then that's a really, really good indicator that you misspelled it. I am not an awesome speller, so I do that all the time, and it just makes these things take longer. But okay, trying to think of so the console can give you not only print line information, but it can also tell you when something's not working. So if you see text in red, that's an error. Sometimes it's a little hard for us to like see hundreds of red lines scrolling by really, really quickly, and some people will take that personally and feel really defeated, like they've really, really messed up. It's usually one error that causes like this cascade of errors, and don't worry about it. It's fine. Eventually, we'll get into a point where we're running more robust stuff. It's also, another thing I'll do is almost always when I'm coding by myself, keep the force quit window open, because you'll end up force quitting a lot, because you'll write programs that basically freeze your operating system, and then you'll have to force quit them. That's also super normal. Don't worry about that. Okay. So this step is going to be a little bit more robust, and I'm going to walk everyone through it a little bit. But we're going to start placing a map in our gray window. I mean, I know it's a lovely shade of gray, but we're going to obliterate that with a map, and we're going to use that map to start mapping our data on. So that's going to be the basis for it. Also people who with computer science backgrounds, you might find the precision of this exercise to be maddeningly inaccurate, and the public data people are going to be like, this doesn't look right. It's just a sketch. It's just it would take a super long time to make it super precise, but it kind of gives us a sense of how to map things with code, and that's really the point. But first, we're going to have to call up a variable. So a lot of variables in processing and any kind of coding environment are usually a place to store numbers or strings, but processing is set up in a way that you can actually create a variable of a map. So you can basically say, hey, we're going to be using an image. Sorry, I said a map, I meant an image. We're going to be using an image within the script, and we need to create, before we do anything else, we need to create a space in that program for that image to be stored when we run the program. So we're going to make the first line this p-image map line. Sometimes you'll get red errors. That's bad. Sometimes you get orange errors. Not as bad. In this case, it's just kind of they're like a heads up. In this case, they're like, hey, you've created this variable for storing an image, but you're not using it. You might want to use it, and it's nice. But don't worry about it if you see a bunch of orange variables. It's just trying to help you out. Okay. The next step is to be a little bit more precise with our program. We're going to create a void setup and a void draw. These are two different functions that are already very established and robust within processing. Void setup lets us do things with the program before it starts to run. and void draw is the running of the program. So if there's something you need to do before you start drawing, your computer starts drawing things, you do it in void setup, but then the things that the computer does happens in void draw. So it's kind of like think about saying like a framework for things to happen. Setup is a framework for things to happen in draw, if that makes sense. All right, so I'm now going to create the void setup, and then we're going to within. Well, let me just do the void setup first. So by creating void setup, yeah, we're gonna get an error for a second here, but bear with me. By doing the void setup, you're basically saying, okay, the parentheses are the inputs for that function, which there aren't any for setup, so there's nothing there, but we still need to say, okay, we're aware that this is a function that functions normally take input. We're indicating that with the parentheses, and then the squiggly brackets, that's where the stuff happens. So in this case, we want a void setup to happen. When we run it, we want to load the image for Albuquerque map, which I'm going to talk about in a second. But let's just write the code first. So, we're basically, in this case, we're saying, so if this top line here is saying, hey, we're going to be using a variable in this script. It's going to be an image variable, p-image variable, which is just an image variable. And there's creating a space to load an image or save an image. And then in void setup, we're saying, okay, this variable that we've created, map, equals loading the image Albuquerque map.png. So, there's something, this is so helpful. Let's say you see a function, you're trolling the web and you see a function and you're not really sure what it does. And you've downloaded a script and you're looking at it. Or you're typing, there's a guy who's doing a class and he's typing these commands and you have no idea what he's talking about and what all this does. He kind of answered the question, but you're not really sure. If you right click on that in processing, you can go to find and reference. And this is fantastic because then it'll go to a web page on processing.org of that command. So then you can get more help about what it means. If you're anything like me, when you first started looking at this stuff, or the first couple times you go here, you'll see a whole bunch of code and it doesn't help you understand anything. But that changes. Eventually it gets more familiar, parts make sense, more and more parts make sense, and you'll get the hang of it. If you go to processing.org, there's also another really, really helpful area, which is the reference. These are all the main commands of processing. So if you're not sure what you want to do, but you kind of want to see what the range of options are, or if you want to get ideas for things you can do, this is definitely a great place to look. I've solved so many problems by going to this page and just looking at different things, and it's saying, oh, well, maybe I could use that to try to do what I thought I was trying to do, but just going about it a different way. It's super, super helpful. So that's those are options for you while you're going through all this. Okay, so we have the map. We have the variable map. We've told it that the map is going to contain the image of load image which might seem odd because where are we loading the image from? Aha. If we go in processing to sketch, show sketch folder, we're then going to go to the folder that I sent you guys through Eric. Thank you, Eric. That has has Albuquerque map.png in it. It has a CSV file, which we'll be using in a second, and the processing file. So if you're doing very light sketches that are kind of not very resource heavy, like, you know, PNG files and spreadsheets that are less than a meg, you can just keep them in your sketch folder, and it will and when you say load this file, processing will automatically look for that file there. So it's pretty streamlined, pretty easy. It gets a little bit more complex if you're trying to refer to things that you can't save on your computer, or you're referring to more sophisticated information. But just to get you started, this is the best way. Okay, so we've got a void setup function, and the trick is we need to put the stuff in a void draw. Once we've created that, we can't not have stuff outside of it. So we need to put these things in a void draw function, which will take just a second. So we'll just do the same thing. Notice that, like, when I'm creating a function, I'll go ahead and create the first squiggly bracket, the second squiggly bracket, and then like up arrow into the space in between right there. This is a way to try to avoid forgetting the last bracket. And when you start getting nested functions, it can get really, really messy and harder to debug, particularly since you get like null pointer exceptions and things like that that don't really tell you that that's what's missing. But all right, so void draw. So if you just type void draw and then the parentheses and then the open and close squiggly brackets around the things, you should see your error messages disappear. If you hit Control T, it's kind of a, whoops, I also hit Control R that time too. That's just a fat finger thing. But the Control T will then format your script with different indents and things like that. It's really, really helpful to kind of keep visual clarity for what you're working with. So I would definitely recommend getting in the habit of doing that. Control T, awesome, great formatting. And then we'll just do, before the println, go to just create a few lines to write with. And then here you can just use the image function, which is drawing an image. And then it will be using the image that's saved or that has been loaded into the map variable, and then position it at 0, 0. Now, when we run the script, you should see the top part of a map and a circle. Majora, do you have a map? That's awesome. Karen, do you have a map?
No, but I just found a zip file.
The thing about the zip, I mean, just like honestly, like yeah, that happens every time I do one of these, and it's actually the best thing is to open the zip file, and then even though you've written everything probably in a different file, to go ahead and write it in that file that you're opening, just because that will actually save all the data in the same place. Otherwise, it'll be, we'll probably be debugging for the next 2 hours. Sorry, you guys did not need to hear me excel like that. Is everyone seeing a map? No? No, this is why I'm here. Hold on, let me take a look. pro coders, you guys have already like written amazing software with processing. Yes? No? Guess not. Just coffee. What's that? Oh. Yikes. Okay. Let's go to the next step. Okay, so maybe you guys noticed that we were placing a map, but it wasn't exactly a map that we could read, and it certainly wasn't a map of Albuquerque yet. That was because we haven't gotten into how big the window is. So the window is actually too small for the map, and we need to make the window the right size so that we can read the map. So in this step, it's pretty simple. We're just going to change the window size. So in the setup, we're going to type in size and then these two seemingly random numbers afterwards. But these are just the pixel sizes in the X dimension, across dimension, and the Y dimension. Right. And now we should see a map of Albuquerque, from which I downloaded from the internet. So I don't, yeah. And it's definitely not, we're going to be positioning things with a big degree of inaccuracy, but it's beginning to code, not crushing code. Map? Okay. I can also stop calling on people if it's like annoying. You know, if you're just here hanging out, like just tell me and I'll ignore you. Eric, is processing coming back to you okay? Is processing coming back all right?
Oh, yeah.
Yeah.
I'm just trying to figure out the size of my screen.
Okay. Yeah, it definitely forces questions about our computers that I've never really considered before, but when you're actually designing things for it, it calls that question. Does anyone is everyone who's trying to make a map making a map? Yeah, sure. Oh, totally. I can even make the font a little bit bigger if that's going to help the picture. Good. So we have yeah. Unfortunately, I believe that Discord's automatic welcome XL, we hope you brought pizza is their kind of joke. Unfortunately, it's not actual pizza.
Tag, you're it. You gotta go get it.
Yeah, I know, right? Yeah, exactly. It's kind of like the inverse dibs. You've been nominated. Go for that. we were just debugging so a little bit of code. The location, if you're following at home and you're getting an error when you're trying to run the window with a map, and you're not finding the image, make sure that the image is in the sketch folder of this file that you're using. So I was trying to avoid that by having everyone start with a zip, but it inherently there's going to be, it's an easy thing to miss. If I was taking this class, I would have just started running a script and wouldn't have followed any instructions. So, I'm very sympathetic. I get it. And really, if you are finding that you're making a window that's too big for your screen and you want to scale it down like Eric did, that's totally fine. That won't mess with anything at all. So feel free to trim it down if it's too big. Karen, do we have successful mapping? You're getting there? Okay. If you guys aren't, if anyone's not a fan of late 90s, early aughts kind of obscure hip hop, you might not know who the guy in the lower right hand corner is, but he was MF Doom, who passed away this last year, and was not, for some reason wasn't public for like 3 or 4 months. His widow kept that on the down low, and then let everyone know. But then he still released a posthumous album. So he felt like it should have something there. There's also this big gray corner that was really ugly, and I just wanted to fill up with something. So MF Doom it is. Hey, it seems like Karen has all the support she needs, and I am just trying to make the people at home feel like they're actually watching something. This is for you guys. We're good? No way. Awesome. Yes. Fantastic. All right. Cool. That's awesome. And like the cool thing about this is like, yes, anyone can do this. I mean, it's just typing really. And then once you do it, it's actually, when you've been struggling, it's so much more satisfying to like see the maps show up, and then you're like, what? Like I just made this. It's like magic. It's kind of like this. The spell enchantment worked. It's awesome. I'm definitely hooked on coding myself. Okay, next step. So there is, so now that we have a map, we can start mapping things onto it. And this is a very sort of imprecise way of mapping, because we're not using GPS or GIS information. We're just using a bitmap that's has blurry pixels and is not really that precise. But we can get kind of approximations and sketches and sort of proof of concepts that then we could build larger, more robust programs around for later. To get the information in this case, we're going to be using that CSV file that's also in the sketch folder. So if people who are just digging through folders and putting things in the right places, this is great, because now you're totally sure that a CSV file is in your folder that you can now reference. So well done there. The first thing we're going to do is we're going to create a table, a variable, which is going to basically create space for the data from the CSV file, which is comma separated values. It's a really, really light form. Yay! It's a really, really light form of storing lots and lots of information. It's really easy for computers to read and very, very difficult for humans to read. But we're having a computer decode this for us, so it's going to work out great. So first step, create a table variable and name it table. So the orange text is the kind of variable that you're creating. In this case, we're creating a table, so it's going to be a whole bunch of values stored in what processing calls a table, and then we're going to name it table with an underscore with a lowercase t, and it's going to be, that's the black text is the name of the variable. That could be anything you want, but don't change it right now because you'll probably refer to that variable later and it gets messy. But just follow along with it for now, but you could name it Miriam or Mark or whatever. So first step, initiating a, instantiating a variable by saying, hey, there's going to be a variable in the script called a table, and then naming it. So when you refer to that variable, processing knows what you're talking about. So the next step is going to be in void setup. Very similar to how we're saying, okay, the map is going to be, that variable will be filled by loading the image of the Albuquerque map. The table will be filled by loading the table of the CSV file that we have saved as well. So I'm going to type that out right now. So table is being filled, the information, the variable that's open is going to be loaded with information through the load table command. The first value is the name of the file that we're loading in as a table, cabq.publicart.csv, which is what you guys should all had. The second value is just saying that there's a header. So this is super helpful because the first line of code in that CSV is actually saying, hey, these are the different kinds of things that are going to follow in these columns. And this is a way of telling processing, hey, you can grab information from that header by using the subcategory names in those headers. I would show you what that looks like in Excel at the moment, but it's actually, it's just, if you've used spreadsheets, that makes sense. If it doesn't make sense, don't worry about it too much. Just if you're going to, typically you're going to want to have a header, but if it doesn't work, then delete it and it'll probably work. Okay. So now that we've told processing to load the data into the header, into the variable, we're now going to tell it to draw stuff with the information from that file. So the next set of we're going to add three lines of code here that is basically loading information into our processing script. So the first one is table row, which is basically saying, hey, there's going to be another variable, table row. that's going to be a row in the table we're going to call row, and we're going to be getting the second row from the table through the get row command, table, and then a subfunction dot get row, and then in parentheses 2. Float, there's like a float command that's a number variable, I'm sorry, a float variable. That's a number that has decimal points per lat, and then the latitude, and then the longitude. If this stuff does not make sense, don't worry about it. Like, this is kind of heady, mathy type stuff, and really not the most important things to take away from here. If you're working with data and you're really want to, all data is going to be different. And if you really want to have the data drive the aesthetics, you'll find a way. Don't worry about that. What's much more important is that you kind of figure out that this is bringing information into the script and doing something with it. In this case, we're just basically saying, hey, grab the information from the second row, and then within that row, there's a column, latitude, and a column of longitude. Grab those two values and hold on to them because we want to do something with them. That's it. So if you're doing this right, you should have two orange errors, which are basically saying, hey, you're not using the floats lat and longi in your script yet, which is kind of the sort of heads up kind of error. It'll still run, but it's like, you're saying you want to do something with this, but you're not doing anything with it yet. We'll do it in a second. But if once you have the script, go ahead and run it. And even though this won't actually change the graphic at all, it's good to run scripts early and often, because then usually you'll be debugging fewer errors as opposed to like writing a whole bunch of code, hoping it works, and then having to debug like 30. Because when you debug more than one, it's really, really hard to figure out what the issue is. And you want to try to only solve one problem at a time. Which you guys, debug is kind of like such like a computer science specific term. I think it's a little interesting, but like basically all the crew there just did a whole bunch of debugging very, very successfully. And that's what we're talking about. So don't let that stress you out. There's just not like a normal word for it. Like problem solving is too vague or whatever. That's not jargony. Okay, is everyone calling? Are we all up to speed? Are we calling up the floats okay? And we're getting, yeah, okay. So now we can start to shift into having the data actually position the circle that we drew, and that will be. I'm so sorry. I think my coffee's too weak today. I don't know. I am not speaking clearly. I'm really, really sorry. Whew. Hi. Okay. We will. Yeah. So we'll just do the. So we're gonna move towards having the ellipses being positioned by the data in the CSV. So let's move to that. And really, it's actually pretty easy. In this case, we've been saying that we're going to have an ellipse, and no matter what's going on within the script, no matter what else, it's always going to be at 50, positioned at x equals 50, y equals 50. And that's fine. That's totally all right. The thing is that now that we've created the lat and longy floats, we can then say, hey, instead of being at 50-50, we can swap those out and say, hey, wherever there's wherever we've said the value of the latitude is and the value of the longitude is, that's where the ellipse will be. So we'll just, all we're doing here, and this is this is one of the most important, but one of the easiest steps, but one of the most important, because now at this point we're having the data drive the graphics as opposed to the graphics being driven by something arbitrary like being just at 50-50 because that was the middle of the default size screen. So that's it. We've loaded up a table. We're grabbing, we're saying, hey, for that table, select the row, the second row, because that's the 2 here. Get row, get the number 2 row, and then within the row, grab the latitude and the longitude values, and use them to draw an ellipse. And I totally forget where this piece of art is. So when I first started teaching coding, I would get like really nervous and want to make sure everything went right. It never did. The thing is, though, is that the great thing about having things go wrong is then I can show you guys what I do when things go wrong. So then you get a better sense of what to do when things go wrong for you. Yes, thank you very much. I appreciate it. It's like embracing the wipeout, just knowing that things won't go right, but that's coding. Is that like they don't go perfectly? Okay, so what we can do here is because there's already a println that's kind of a relic. We were saying "Hi world" when we first started, or "Hello world," or whatever you typed in that. Right now, you don't have to println with just strings. You can println variables, and this is how I figure out what's going wrong with things almost all the time. Because if there's an issue with the variable, the information that's being loaded, it's really hard to figure out unless you're actually getting like being shown what that is. So I'm going to change my println to be able to show me what's being stored in that variable, and we'll take it from there. So I often will like write little notes to myself, even though it's helpful in the moment. It's far more helpful if you like leave a script for a few years and come back, which for me definitely happens. Because trying to figure out what the heck I was thinking 3 years ago is really hard unless there's lots and lots of notes to myself. Printlns are a good way to do that. Another thing you can always do is 2 backslashes. So if you have 2 backslashes and then you type anything behind it, It basically is telling processing to ignore that text, and it grays it out and pretends like, according to processing, it's not there. But it's great for humans to read if you're working on a team or sporadically, that you can then see notes to yourself, and you can like leave yourself notes being like, oh, this block of code does this, or I could not figure this out, or whatever. And it's, to me, super, super helpful. Printlns also do something similar. And because usually they'll let me know where the issues I was running into were, if I have to go do something else and then come back to this. And, you know, writing scripts for me is like a tens of hours process, so that happens. The thing here is that if you do a println and you just print a whole bunch of numbers, that's not always clear. But if you put in text first in the purple quotes and say lat equals, that's going to say before whatever the value of lat is, because you can just print the variable. It'll say lat is that it'll let me know that that number is responding to the lat variable. Yeah. Yeah, there's a whole step that I'm getting ahead of myself on this one, which is there's a reason why this isn't being positioned correctly. Oh, really? Yeah. That makes me feel better, because I definitely could not get all the values to look totally dialed. But that's okay. I mean, you know, we're figuring that out. There is something going on here, though, and I think this will make this next step super clear. I'm just gonna add another println to make it crystal. Hold on one second. Nathan is on it, crushing it. Yeah, here, let me walk everyone else through it. So we're not seeing a circle printed here, but we're giving processing the longitude and latitude. Shouldn't we see it? So, processing is only maps objects within a positive space. So the top left corner is 0, 0. And then if you look at the size value, 169, 0 is over here if you've used Cartesian coordinates. And 1108 is down there. It's a little odd in that the 0, 0 is in the top left corner as opposed to the bottom left corner, but it's just a little quirk. So here in the Western Hemisphere, our longitudes are negative numbers. So we are telling processing to map our ellipse in -100. So that's like it's kind of getting close to the carpeted wall over there. It's mapping, it's happening. We can't see it. So we have to create a conversion process for that. We have to create a way of saying, okay, we're going to take the incredibly precise geospatial coordinates of the GPS and map that to this really busted basic pixel map. And I'm so glad to hear that some of the things were inverted, because I definitely was getting some weird results with this. But let me show you how that works. This is by far the driest part of this exercise, so just bear with me and hang in there, it gets better. I'm confident that people who hate math think that they can't code, and that's like the biggest deterrent to coding, and it's just crazy. Also, architecture. I can't tell you how many hundreds of people I've met. They're like, "Oh, architecture. Like, I always wanted to be an architect, but I was terrible at math." And I'm like, I don't use math. I mean, you know, kind of a little, but like not enough to keep anyone out of architecture. It's kind of silly. So what we're going to do here, and this is a little unfortunate that I called the image variable map, because now we're going to actually use the map command, and it's going to be a lot of me saying map, which, you know, it's just annoying after a while. My bad, poor course planning on my part. So what we're going to do is basically create a new variable, which is taking the value that we have from the geospatial coordinates, or the two values, and mapping them to the size of our window. So there's a thing you can, it's a mathematical function. It's basically saying, given two ranges of values, so from one number to another number, and another number to another number. Think in this case, the width, the latitude of that is being represented in the image, and the actual pixels that are in the image. If you take a value and you say it's between the first range, it'll actually get remapped to the second range. You guys are cracking up at me. You guys are. You're just laughing at me. It's all right. You're like, why are we talking about this? This is like really, really important. It's huge. I do the same thing. I totally get it. Okay. So all we're going to do here is remap the numbers using the map command. And basically, these are numbers that are very, very big and very, very precise in the geospatial coordinates, not so precise with the other ones, but we're basically going to say, take this general GPS coordinate and map it onto the window. We're going to create a new float. We're going to call it mapped lat. So it's just the lat value that's been remapped to the window values. We're going to call the function map, and we're going to give it the lat value. And then the first range will be defined by the geospatial coordinates that I was able to kind of gauge from Wikipedia, and the map being like, okay, that's El Pinto up at the top, and we're going to use, you know, El Pinto is located at this address, which apparently is at this GPS. It's not very precise, but it'll work for today. So using the map function, giving it the lat variable, giving the first range of 34.9 to 35.2, then the second range of 0 to 1108. If 1108 seems familiar, that's because that's the size of the window in the Y dimension. And then we're going to create another float variable that is going to be the mapped longitude, which is going to be the same thing with just different numbers. I'll type this all out and then leave it up there somewhere. If you're having trouble following along when I'm typing, that's just hang out for a second. I'll bring it up in a second. So try to type these two lines as closely as you possibly can. I'm pretty sure my son is going to claim this t-shirt. He really likes the design. I think that's it's not going to be in that mine for very long. He's very much a t-shirt thief. All of the organization team got to know my daughter very well. They didn't get to know my son as much because he wasn't hanging in my office. But my daughter, she liked to interrupt our meetings. A lot. It was like the Thursday afternoons was the one time my wife was always out of the house, so it was just constant, like, Naomi was in there, including the game of hide and seek 2 days ago. It's pretty hilarious. She'll be like, okay, she's 3, so she'll be like, she'll be playing with her friend will be like, okay, you hide. She'll be like, okay, and she'll like literally like go like this, and then jump out. It's amazing. Okay, are we feeling comfortable with these lines of code? Is anyone still typing? Okay, so now the trick here is just in the ellipse line, we're just gonna make sure that we take these new mapped variables and give them to the ellipse to create an ellipse within this, to take the GPS information and turn it into something we can use with the map, because we don't want the circles to be mapped on the wall, that we want them to be actually in the window. All right, so mat longi are now driving the location of the ellipse. Again, the first two inputs are the location of the ellipse. And the ellipse is still 10 by 10. We're probably going to leave it there, but that's all you need to make a circle. Which this piece of, so you can see it now. It's on Edith. Pretty sure this piece of art's supposed to be on Rio Grande, but that's beside the point.
Yeah, and I got an error message really, or not an error message, but something that needed me to authorize Windows to. Right.
We're running into the kind of issue that I believe Windows is Windows related. We're not sure. It might be, but it's the kind of thing that Mac users are like, and then and then Linux users are like, I told you, I knew it. So if you guys have at this point, you guys should have a dot on the map that we're finding to be a kind of, there may be some sort of disconnect there between the typed in location and the GPS, because it's in the CSV it says it's on Rio Grande, but it's for Albuquerque natives it's being marked on Edith. Yes, do we figure that out?
Well, I just wanted to mention something I found interesting
Yeah.
a couple days ago, which is that all of those geolocations were apparently hand-entered a long time ago.
Okay, I no longer feel bad about the fact that I spent like an afternoon being like, why is this not mapping to where it says it's supposed to map? Because the data has like the addresses, and then it has the geo coordinates, and we could use the addresses we could create a much more sophisticated computer or program that would call up the addresses, get the coordinates, and then translate them, and then map them. But that's way harder, and we want to do more of the fun stuff, like what happens once we start mapping things. But I really did want to make sure it was precise, and now I understand that is, okay. That's huge. That helps. And that's the thing, it doesn't mean that this exercise is invalid or anything like that. It's just, we try to do the best we can with the data that we have, and actually that is kind of going to prove some later points of the presentation anyway, so that's great. Okay, so at this point we have a dot, which is nice, again, yeah, huzzah. But let's I think the next step is to put dots for all of the pieces of art that we have. in the file. And I was getting kind of conversion errors going between a spreadsheet and a CSV for some reason. I will. So we're only going to use the first 100, but we should start working towards mapping that 100. So for those of you with coding experience, seeing my notes on in the left window is probably not much of a surprise. What we're doing now is we're creating what's called a for loop. So this is one of the most robust things we can do in computer coding, which is once we have a single exercise. What? Karen, what did you do? Oh, awesome. Okay, cool. Fantastic. All right, we have success. So basically the kind, and this is a very common workflow for scripting, is to figure out how to do something once really well, but then tell processing to do something lots of times, in this case 100. So right now we're saying, okay, get the second row of the table and do something with it. Now we're going to say, do this 100 times. And this is a kind of a weird piece of syntax if you haven't coded before, but it's super, super helpful. It's basically saying, so after the image placement and before table row, type in for, and it'll turn green, which is saying it's a conditional statement. And we give it 3 pieces of information. An integer, I. Integer is a number value that doesn't have decimal points, so it's a variable in that case. Integer I, which equals 0, semicolon, I is less than 100, semicolon. And then I++. Really important to close the parentheses and then open a bracket, create an open bracket, and then scroll down to underneath the ellipse and close the bracket. Someone will not do this, and that's okay, but it's what happens. Hit Control-T for formatting. Okay, the for loop is basically saying for a number, for this value, I, we're going to start it at 100. As long as, we're going to start at 0. As long as it's under 100, keep on doing this stuff, and after you do all that stuff, the I++ is adding 1 to I. So basically, the first time you run this, it's I is 0. You do this whole block of text, and then at the end of it, you add 1 to I, so then I is 1. Do it all again. Then I is 2, then I is 3, then I is 4, and you keep on doing this until I is 100, and then it stops. The trick here, and this is also a super important step, is instead of get row number 2, we're going to say get row number I. So we're going to start by grabbing the first row, the 0th row, then the first, second, third, fourth, and I'll keep on going through all that stuff, grabbing information from each row and doing the saving of information, the mapping it to a range, and then creating an ellipse on it. And if you do this right, you end up with quite a lot of circles. A lot of them are in spots that are very unlikely to have public art, but that's okay. Handwritten GPS code. Madrone, did you have some success? Fantastic. Very glad. It's really kind of fun, isn't it? Of course, don't look at the locations of those circles too carefully. Unfortunately, after 2004, I kind of just stopped watching.
blessings and loads. Loaded one location, not loading around.
This is fun.
So, while we're catching scripts up and things like that, it's you know what? Let's take a break, and I'll check Discord and see what's going on. I just want to pause this for a second because we've been going for an hour and a half, and I know that some people are already sneaking off to the bathroom. So let's take a bio break. And we'll just reconvene at 11:45 because we're gonna shift gears a little bit and start talking about kind of what this stuff means, how it works, like what are we really doing when we map data? Because that's, even though I teach a lot with this stuff, a lot of my research is kind of in those areas, and might be able to add a little bit more value with that stuff there. But yeah, let's take a break, get some coffee, regroup, and then I'll answer stuff on Discord, and then I'll see you guys back here at 11:45. Cool.
Yeah!
Yes. We're coding. Oh yeah. Oh no, I think in case they have questions. Yeah, and then I might encourage people to use. That's awesome. Yeah. So one of the other sort of peculiar aspects of my approach towards teaching code is that a lot of my research has to do with artificial intelligence, and particularly in the built environment, and a lot of that is really arguing for actually seeing AI as much more equals than sort of servants. So I kind of come with a bias of communication, that we're kind of creating things that communicate information to other people, which is basically what architects do. We don't actually build buildings. We create drawings that then people use to build buildings. We create diagrams to explain why the building is going to be good, or at least why we think it will be good. And then sometimes we'll create a sort of dynamic representations of like a built environment of an urban context to show how different kinds of patterns and behaviors, and that's where a lot of my work with processing comes in. All of that is to say that it's really worth noting that while we're learning how to code, and we're in this case we're using processing, which is a really great graphic interface, and for a while people were saying there's a big robust discussion whether or not processing or Python should be taught to intro-level computer science students. Python's easier, it's also much more robust, but students would respond so well to processing because the graphics were so great that they'd feel like they made something cool, and then they can, they keep on doing it. That was an argument for 5 years or so. But so you guys are getting a lot of skills with graphics, and at this point, we're kind of doing something like that you could do with Google Maps. You could create a bunch of points on a Google map, and then you'd have the same thing we've done. The idea that I really try to push is, what are we really trying to communicate? So a similar project to the one that Sherry described about the us finding out where pictures of cats were mapped near public art. There's actually there was some useful information about that, but I think through my, maybe not that project, but that class, there was some good stuff. But one of the things I think is really interesting to me about having the work I've done with big data is that big data is sort of a different way of knowing than other forms of data. So another project that I worked on, not with the collaboration with Sherry's office, was mapping in Seattle keywords from Flickr images in a neighborhood of Seattle to try to see where the happy zones were and where the sad zones were. So like a bunch of negative words were called out and mapped, a bunch of positive words were called out and mapped. And this was another instance where it turned out that most of the geolocated images on Flickr about in this neighborhood in Seattle were photos of people's cats in their apartments, and had no relevance to the built environment, or none that we could see. And that's, I think, where we get a little mixed up with big data. Big data is by definition information that we need a computer to understand. But in that process of understanding, we're tapping into a different form of intelligence that communicates with us really, really differently. A way to think about this is, has anyone ever seen the College Humor thing, If Google Was a Guy? Yes? Okay. It's basically like, imagine Google is a guy in an office, and people sit down at his desk and they're like, foot same length Europe, or Outlook looks surprised why? And they're using the syntax that we use with Google to communicate with this guy in his office, and it's ridiculous. The point is really driven home when I think it's the third episode of this, there's an anthropomorphized Siri kind of like Steve Jobs, mock turtleneck, coiffed hair, looking very kind of designy. And she's like, Siri, how big is the Serengeti? And she goes, no problem, and looks at Google and says, show me pictures of spaghetti. And like it's complete, and it's exactly the thing that we've argued with, where we try to use our language, our syntax, with Siri, and it doesn't work. But we've already adapted to Google in a way of using keywords, taking out verbs, pronouns, prepositions, things like that, and just going with understanding how to communicate with Google much more effectively. When we're dealing with graphics and mappings of data, it's actually not that dissimilar. There's this phenomenon that's happened in design schools for about 20 years now called data smog, where you have a very ambitious student map out some insane amount of data, and it's just like all these points on a map that make this incredibly complex graphic that looks amazing, but no one has any idea what it means. Like it doesn't actually tell us anything. It gives us a sense of the complexity of the information, but it doesn't really tell us much. So one of the things that I think is sort of a very successful way to think about how to use big data to be able to communicate information is to actually not try to use these scripts to create graphs or maps in sort of a very specific sense where you could use to find locations, but to actually think about these kind of mappings in terms of like creating objects with behaviors that emulate certain kinds of behaviors within the city. And an example I can cite was a thesis student that did something similar, basically did this kind of mapping about using big data to try to understand social dynamism within the kind of the UNM campus and the Nob Hill area. And what he found, and he did a live mapping and for his defense, and he showed, and it was this kind of strange thing where there was this sort of hole in the place where the Denny's was. If you guys, Breaking Bad fans, the trunk scene, now it's the Chipotle and Jersey Mike's. But basically, he was saying I don't know what's happening here, and I really don't know what's happening and why this is working. But there seems to be like an anomaly at that Denny's, which if you ever ate at that Denny's, like no one went in there. I don't know why. Like the only people who went in there were like German tourists who were like, this is Breaking Bad. Oh, cool. Right on. Like, and that was like it. And we don't get a lot of those. I worked next to it for like 4 or 5 years. I don't think I ever went in. I don't think I ever saw anyone in there. It was a social vacuum, but he was able to tap into this complex of behavior and identify that there's something missing there, and that was an opportunity to rethink that part of the urban environment. That really, there's a lot of ways to get that information from other ways, and it just happened to be the case that that Denny's was torn down, and it's either the Freddy's or the Chipotle is there now. I can't remember which side of the street it was on. Yeah, I think you're right. I think it was Freddy's. So it was next to the gas station? Yeah. So and that gas station was a problem too. I did go there for snacks because the architecture school is like right across the street. So, but I think it was the Chipotle, which is now actually, even with the pandemic, it's still like super crowded in there, which is probably not a good thing. Anyways, so one of the things that we're trying to do is really think about how we can start to set up behaviors within the script that can tap into stuff that's hard to just quantify with numbers, right? There's this kind of myth out there that if you can't run a simulation of something, it's because you don't have enough data. Bogus. We have plenty of data about the dripping of water from a faucet, but we can't simulate it. We can't. That's like totally. It's stochastic. It's completely unpredictable. I work with a guy named Mark Stone who makes 40 foot by 80-foot models in the basement of Centennial to basically create mock-ups of hydrodynamics in areas around Albuquerque because you cannot model water behavior accurately with computers. But if you make a physical model, you can get relatively close, which is fascinating to me. But we live in a time of like rampant techno optimism. Everyone's like, oh, Moore's law. We're gonna have lots and lots of machines that'll do anything. And there's actually been really robust discussions about the limitations of machines and what they can do and what they can't do for the last 50, 60, 70 years. So all of this is to say is really thinking about what kind of things might be enabled within these maps, and not necessarily think of them as sort of as like simulations or representations of something that like something quantifiable that exists, but possibilities of creating similar dynamics within these settings that then help us understand the real world, which is a subtle shift of habit of mind, but like a super, super important one, because when we get into big data, it's really hard not to just make data smog and not to map a whole bunch of information and be like, ta-da, and then people will be like, that looks cool as hell, man, but I have no idea like what to do with it or what I can even do. And so this is where I think getting into creating objects, and when processing is an object-oriented programming platform, getting into the creation of objects that have behaviors and basically letting these little creatures run amok is, one, it's super fun, but two, it's actually a far more productive way of using this tool. So that's what we're going to start to do now. We're going to start to kind of script some kind of behaviors into this. What I'm going to do is walk you guys through one script. Then I'm going to show you a little bit more of a robust script, which I promise you, we should have when I run it, if we could have a camera on Sherry, that'd be awesome, because like, reacting to the script I'm going to show, dude, it's going to be awesome. But we'll get there. And then what I'd like to do is actually talk with everyone here, and if you guys are online and you want to ask me via Discord, I'd love to be able to, you don't actually have to get Sherry, sorry. But I'd love to be able to like talk with you for a second and talk about if you have any interest in like where you want to take this and like where you'd like to, like things you'd like to be able to do. Because I might be able to point you in a little bit of a direction and maybe be able to like help you take the first few steps and then kind of coach you through what you do after this course. So with that being said, yes.
I did want to say one thing interesting with what you're talking about with the environment. If anybody's interested, there's actually a lot of studies on like simulation, like SimCity type simulations, and the like backwards reflection of what we think should be simulated and like how we think that gets simulated, and trying to decode that in order to see what the SimCity thinks is like an ideal.
Right. I mean, that was the kind of thing, I definitely, with my first experiences with SimCity, it was they would like have this sort of very specific kind of a formula for this balance that would like, if you got that balance, then you won, you'd have a thriving city. But like, how that related to a real city was always kind of curious. This is super fascinating stuff. And when we get into like, if one can accept that things like hydrodynamics are by definition, and this is kind of a contentious point. So if you don't agree, don't worry about it. But like if you accept that like some things can't be simulated, then we kind of get into the really interesting issue of can human behavior really be simulated. And there are very prominent architects that are using crowd modeling scripts to design their buildings to basically anticipate human behavior and then design for it. And if you were to watch any of these videos, you would be very dubious about them because they don't look like human. It doesn't look like human behavior to me. Plus, it's actually much more fluid dynamics, which is ironic. But there's not much of a feedback loop. So a lot of these simulations that people proclaim, like, oh, we can anticipate what's going to be happening in the environment here or with crowds going through the store, like they don't then say, okay, we're going to build that and then check to see if it works, which is this weird thing that architecture's in. Like, if automobile engineers were like, oh, this car is going to do 0 to 60 in less than 3 seconds, but they never actually like test, they did it in a model, but they didn't actually test to see if the car actually did that or not, that'd be kind of a problem. But design gets into a whole different thing. Anyways, sorry. Used to talking to designers and architects and stuff. Okay, so the first thing we're going to do to make this a little bit more funky is to add 2 float variables up at the top. These are what's called global variables. So they basically can be accessed by the entire script all the time. So we're going to add a float called frames, set that to 0, and a float called frame add, and set that to 0.5. No errors. Everyone's okay. Okay. Because I just want to make sure, because I do have to scroll down a little bit. I just want to make sure we got this. It'll probably be fine. So we've been using functions so far, but we're now going to create our own function. This is going to be basically a this is just going to be a way of having. It's going to be the first step to creating an object, which is an object in programming is a set of code that contains functions and then variables that are local to that object. So like it's like a thing. Think of it as like a block of code that has memory. So we're going to create our own code, and it's going to be our own function, and it's going to be called it's going to be a void called pulse. And I'd strongly recommend opening and closing the parentheses, and then opening and closing the squiggly brackets. This is a habit that will save you days of pain if you stay to stick with coding. So within our variable, we're going to have 3 inputs. There are going to be 3 floats called mapped longi, mapped lat, and mapped frames. A note that they have underscores in front of them. This is not something you like structurally have to do, but it's kind of a good habit in terms of code writing, and it's kind of a convention that'll allow you to allow someone else to look at your code and kind of quickly realize that, oh, the values in this function relate to the same named values in the actual the main script. It's just a way of kind of creating a reference there, but then not getting into like duplicating the actual names, because that gets into kind of syntactical issues eventually. So anyways, add the 3 floats, mapped longi, mapped lat, frames, and just add an underscore in front of them. And you'll see you're getting the yellow or orange squiggly lines underneath and errors there saying, hey, you're not using these variables that you created. That's okay. We're going to use them in just a second. And now we're going to just copy and paste the ellipse function that we called in the main body, and then paste it in the function that we're creating. So copy and paste is kind of like every other program, just Control or Open Apple C, then Control or Open Apple V. And you'll see red error messages under the mapped lat and mapped longy. That's because you haven't called those variables in this function yet, but or you haven't instantiated them. But you're going to, if you just add the underscores, then the errors will go away. If the underscore thing doesn't make sense, don't worry about it. It's like literally the most confusing part of this whole script, and really something that took me several years to get my head around and had to take like classes to figure out, really. So just hang in there. So we still have one issue left. That's with our pulse function, in that we're not using frames just yet, the underscore frames variable. So we're just going to add that to 10. So this is going to be a way for the value of the radii of the circle to increase and ultimately decrease while we're graphing them. So just add underscore frames to the 10 value, like so. So your pulse function should look something like this. And if you run your script, nothing will happen. It'll be exactly the same as the one we had before, because we actually haven't. We've created this function, but we haven't actually said, hey, run the function. We've just said, like, this function exists. And now the next step is to tell processing that we'd like to actually run this. So go ahead and put 2 backslashes in front of ellipse. That grays out ellipse, so then you don't have, so we're not going to be so we'll be able to draw our ellipses through the pulse function as opposed to calling the ellipse function directly. And then we'll just say, hey, the pulse function, we're going to say in the line above that we're going to call the pulse function, and it's going to run. Yeah, so we're going to call it pretty similarly to how we have it below. Set up, we're going to say pulse and then give an input for underscore map longly, underscore map lat, and underscore frames, and they will all be those values without the underscores. Again, if that's confusing, don't worry about it. It's okay. It just works. All right. So if we run the script now, also no change. Yes, success. In that it's not success. It's happening predictably. I guess that's successful. Yeah, we haven't. So we've created basically the exact same thing that was happening before, but by creating a function, we've been able to add the capacity to remember values, or to track more complex numeric relationships. So we're going to just add a little bit of code at the bottom of our script. It's not in Pulse. It's in the body of void draw. That we're going to say that frames equals frames plus frame add. And what this will do is basically increase the size of frames basically every time we run the script, which runs 60 times a second. So that's what makes processing kind of dynamic, is that it's this kind of live action thing. So as values change, so do the objects on the screen. So all the work we've done so far has just been kind of a framework to basically make this last piece of code meaningful and make it mean something. Which means chaos. Because what's happening, this is kind of similar to the script of the loop print, go back to 20, where we've told processing to make circles that basically expand forever. They're still expanding. We can't see them expanding, but they're, according to processing, they're very much still expanding. So we're gonna mitigate that a little bit. I can't begin to describe how much I appreciate how much Madrone enjoys this. It's very sympathetic. It's basically how I did it. This last class, I was teaching online this spring and doing lots of Photoshop stuff. But basically the goal of like in-class exercises was like, do this until you laugh. And like I had a bunch of students be like, wait, seriously? And I'm like, no. Yeah, I want you to do the live. It might be like 200. You might have to post 200 of like that face that you found, but like do that, and then that's success. So we're on the same page. Okay, so yes, it's hilarious. So we have ever-growing donuts over Albuquerque, but we're going to add a little bit of code to kind of make this a little bit more controlled. We're going to use an if statement. An if statement is a conditional statement that basically says, if something happens, then do this. Which, in this case, we're going to say, hey, if frames gets past a certain number, then make it go back down and not expand forever. So, useful at this point. And I'm not going to go into this too much. This is a compound if statement. This is a lot more complex than most if statements you guys will write on your own, but it's just going to save us a little bit of time and allow me to talk to everybody. So just bear with me on this one. But it's basically saying if the frames get to a certain positive, greater than a positive number or smaller than a negative number, then make the value of frames be negative of what it was. So basically reverse it. So instead, Karen gets it. Karen totally gets it. She's like, instead of adding one after a certain point, then you subtract one. But then if you get to too low of a number, then you add one again by just multiplying by -1. I guess there is math in this. I'm so sorry. But it's not very much math. I mean. So what this is saying is if frames is larger than 10, and then the two vertical things, I have no idea what those are called. I've actually never actually used them in class before, but what's that? They're breaks? Oh, that's easy. Breaks. Two breaks means or. So if one of these two conditions are met, frames is greater than 10 or less than -10, then frame add equals frame add times -1. So if you're adding 1 every time and you get past 10, then frame add equals frame add times -1, which means it's negative whatever that value is, and then you'll be subtracting. When you add the negative, you're subtracting. And yeah. So now, way too fast. So I think a lot of the art of designing with these graphics is basically saying, I'm creating a framework, so then changing things like how quickly these shapes oscillate is like something that I can tune really, really easily. So by doing that, or with the intent of doing that, if you are finding that your circles are pulsing at too quickly a rate or too slow of a rate, you can just change the value of frame add. I have mine set to 0.005, and originally it was 0.1 and or 0.5, and it was way too fast. But you can change the value of frame add, and that'll dial in the oscillations or the pulses to the amount that you'd like. Yes. I'm watching. I'm not paying attention. Yes. Probably a squiggly bracket. This is so easy. You have a capital F here. You don't have a capital F there. And that is. Yeah, I'm sure there's rules, but I don't know. Good? Okay. So if that's the case, just add this chunk. Yeah, because you're basically saying, hey, keep on adding a value to the thing that gets added to the radius size and go on forever. Oh, yeah. It'll do that. So, sorry, I keep on forgetting to use the mic. So what I'd like to do, I'm gonna run a much more complex script, which is basically taking the pulse function and turning it into a class, which basically makes a whole bunch of pulse objects that then like run around the script. And I think I'm gonna run it and then just show you guys what it looks like, but then leave it on the screen. And if you guys want to try to borrow parts of it or try to copy it, you're more than welcome. I also can email this to everybody, or I can email all of these to everybody. It's really no problem. It's super light files. But I'll run this, and then I'd really like to talk with you guys and kind of figure out why you came here today, what could, if any of this has piqued your interest, where you'd like to take this. Because in terms of sort of kind of coaching how to proceed, that's actually much more my strength than kind of explaining what to do. But let me show you this one last code. I call this Sherry's vision for Albuquerque. This is my... I mean, I don't want to presume, but like, I'm pretty sure this is the case.
There's little dots everywhere.
This is kind of a much more robust use of the machine and machinic intelligence to be able to kind of understand things that we're challenged to know other ways. So, it's still going. Still.
I know. Okay, so when you rerun it again, this screenshot of like when it's about 50% taking over Albuquerque.
Yeah.
Yeah, exactly.
Also, if do not feel like you have to stick around if you don't want to. You've got to go. It's a long class. I'm used to only an hour and 10 minutes, so this is different for me.